Assalamu alaikum, dear students. Today we have third lecture of chapter number 20, nuclear physics. Okay. In this topic, we will study inshallah mass defect and binding energy. This is also called mass deficit or mass defect. Okay. To understand mass defect, let us take an example of deuterium nucleus. We know that deuterium is the isotope of hydrogen. Isotopes of hydrogens are three. For example, if we talk about protium, deuterium, and tritium, let us consider the deuterium. We know that deuterium has one proton and one neutron. Okay, let us consider. Let us consider. We have a deuterium nucleus in which there is one proton and one neutron. Okay. Deuterium nucleus consists of one proton and one neutron. First, I'm going to find theoretical mass of deuterium nucleus. So first, we are going to find the theoretical mass of deuterium nucleus. We know that theoretical deuterium nucleus has one proton and the mass of proton is 1.0072776 atomic mass unit. This is the mass of deuterium. This is the mass of proton, and we know that the mass of neutron is 1.008665 atomic mass unit. Okay, I am going to add them because deuterium nucleus consists of proton and neutron. So to find the total mass of the nucleus, we have to add the mass of proton and mass of neutron. So if we add the mass of proton and the mass of neutron, we will get 1.007276 plus 1.008665 atomic mass unit. Then we will get 2.001694 atomic mass unit. This is the mass of deuterium nucleus. Okay. This is the mass of deuterium nucleus. Now, this is the theoretical mass. I actually add the mass of proton and mass of neutron, so we get the theoretical mass of deuterium nucleus. Now, I want to find the experimental mass. Experimental mass of deuterium nucleus. So by mass spectrometer, I get the experimental value of the deuterium nucleus, that is 2.0014102 atomic mass unit. This is the experimental mass of deuterium nucleus. So when I compare these two masses, I get surprised because the theoretical mass is greater while the experimental mass is smaller. So actually there is a single proton and single neutron in the nucleus. So I added a proton and neutron and I get this mass. But experimentally the mass is smaller. Theoretically the mass is greater, experimentally the mass is smaller. So the question is where why this mass is minimized, where this extra mass goes. Okay, this is the main question, and it is according to the law of conservation of mass, because law of conservation of mass say that mass can neither be created nor destroyed, but it can change from one form to another form. But here the mass is destroyed because theoretically the mass is greater, experimentally the mass is smaller. So here the mass is destroyed. If the mass is destroyed, so this is the violation of law of conservation of mass. So according to law of conservation of mass can neither be created nor destroyed. Okay. Now, first I want to find how much mass is destroyed, how much mass mass deficit is there. So look at here. So subtract theoretical mass, the experimental mass from the theoretical mass. So we will get. So subtract experimental mass minus theoretical mass. So we will get. 2.001694 minus 2.0014102. So we will get 0.002388 atomic mass unit. So this is called the mass defect. This is the mass defect between the two masses, in the theoretical mass and the experimental mass. This is the mass defect. This much mass is destroyed within the nucleus of deuterium. Okay, this mass is being destroyed or deficit in the deuterium nucleus. Okay, now Einstein said that mass and energy are interconvertible, means mass and energy are interconvertible, means energy can be converted into mass and mass can be converted into energy. So energy and mass both are the form of one another. Okay, so the mass defect is converted into energy. So we know that one atomic mass unit has 931 mega electron volt. 931 mega electron volt. Okay, I want to find the energy. So multiplied this factor by 931, so we will get 0.002388 into 931 mega electron volt. So we will get 2.22 mega electron volt. So this energy is called the binding energy. What does it mean? It means the proton and the neutron has some mass shared with one another, has some mass defect between one another. So that mass defect is converted into binding energy, and by that binding energy the proton and neutron bound one another. The proton and neutron bound one another. So this binding energy arises from the mass defect. So this binding energy shows the stability of nucleus. If there is a binding energy per nucleon is greater, the nucleus will be more stable. So look at here. One is called the binding energy per nucleon or packing factor. What is packing factor? Packing factor is the binding energy per nucleons. Nucleons mean A. A means the mass number or A means the nucleon number. Okay. And what is Z? Z means the proton number. What is A? A means the nucleon number, means proton plus neutron. What is neutron number? A minus Z. Okay. Now, what I did in these calculations I did from the mass empirical formula. Okay, look at the mass empirical formula. The mass empirical formula for the mass defect is equal to number of protons into mass of proton plus number of neutrons into mass of neutron minus experimental mass. Okay, so this shows the theoretical mass and this shows the experimental mass. So I subtracted the experimental mass from the theoretical mass and I get the mass defect. So if we want to convert this mass defect into binding energy, so multiply the whole equation by c square. So we will get multiply the whole equation by c square. So look at here, what we have, A minus Z into mass of neutron minus M. So multiply whole equation by c square. So we will get, so this mc square is the binding energy. So it will be ZMP plus A minus Z Mn into c square minus mc square. So this is the equation for the binding energy of the nucleus. So by this equation we can find the binding energy of the nucleus. So the question is where this binding energy comes from. The answer is the binding energy arises from the from the mass defect between the nucleons. Okay, this is all about the mass defect and binding energy. And if you have any query, then text or comments in the video, or text in the WhatsApp group. So inshallah I'll reply. Okay, take care. Allah Hafiz.